Welcome to Unit 4, Day 1, Classifying Triangles. In this lesson, we're going to talk about classifying triangles by angles and by sides, and we'll move forward from there. In this unit of study, we will be focusing on triangles, and there's a lot of neat things that happen in geometry when we start talking about triangles and triangular relationships. So, this first one, we're just going to quickly review how to classify triangles. If you need to pause the video at any time to copy this down, go ahead. So most of you will probably pause here at the beginning to copy this information down as best you can. When you draw these triangles, try and draw them exactly like I've drawn. Try your best anyway, because that's going to make it a little bit easier for you to follow along with what we're doing. Okay, so we're going to jump right in. Now, as we classify triangles, there are two ways we can classify triangles. One way is by classifying by angles. The other way is by classifying by sides. Now, there are four different classifications for classifying by angles. If a triangle has three acute angles, if each one of these angles is acute, we're pretending they're each a different measure, but they're all acute. Remember, acute means less than 90. Okay. All right. That means we can call this an acute triangle. Okay? If there's at least or exactly one obtuse angle, you'll find out there's the only possible triangles to have one obtuse angle. Okay, they can't have more than one. Sorry, it was kind of a tongue twister. But if you do have an obtuse angle in your triangle, then we can call it an obtuse triangle. Remember, obtuse means greater than 90, but less than 180. And then if there is one right angle, there can only be one right angle, but if there is one right angle, we call it a right triangle. And remember, right means exactly 90 degrees. But if all three angles are congruent, then we call this an equiangular triangle. Equiangular. Right? They would all be the same. Now, here's what I would like for you to do. Before you come into class, I want you to tell me what each of these angle measures has to be, because they're all the same, and all three angles of a triangle should add up to 180 degrees. So you should be able to tell me what angle measure each of those is. It should all be the same number. But we'll come back to that when you come to class next time. Now, for these examples, I want you to go ahead and list this out and number 1 through 5 like I've done. Okay, one number each line. When you get to class, I'm going to give you some examples to either draw in here, or I'll give you a little piece of paper that you actually tape in or glue in. And we'll do these examples in class. So we can just copy this down. All right, we can just have this copied down and then make sure you give yourself 5 lines, and then we will fill the rest of that in when you come into class. So we can also classify triangles by their side lengths, or by their sides. Okay, there are 3 classifications by side. If a triangle has 3 congruent sides, we call that equilateral. A triangle with 3 congruent sides is an equilateral triangle. You notice I'm using the symbol for triangle instead of the word triangle each time. If a triangle has 2 congruent sides, we call that an isosceles triangle. And if there are no congruent sides, we call it a scalene triangle. Now, I want to go back to isosceles triangles. The definition of an isosceles triangle is any triangle that has at least 2 congruent sides. So you should notice that that makes equilateral triangles also isosceles, because they do have at least 2. They just happen to have a third side that is also congruent. And we will use that when we study isosceles triangles and all their properties and realize that all the properties of an isosceles triangle also apply to equilateral triangles. Okay, and then you should leave some space for another 3 examples after classifying by sides. Again, there'll be some more that I give you in class to fill that in, but you should come into class with this notes page filled out and these places, empty lines, leaving yourself enough room to do those examples in class. Okay? Now, whatever amount of the page you have filled up with this, you should have filled up most of the page, especially if you're leaving the empty spaces. I do want you to turn to the back or turn to the next page to do this next part. Okay, so we are on the back side of that page, or if you need to start a brand new page, you can do that. But we can also classify triangles in the coordinate plane, and we're going to use the distance formula for that. Okay, this is a formula you should remember from Unit 1. We used it a little bit in Unit 2, I think, also. We can use that in the coordinate plane to help us figure out classifications for triangles. And so I'll explain in just a minute how this is going to help us. But in this next example, again, pause the video to make sure you can copy it down. We are to find the measure of the sides of triangle JKL. And so we label a triangle by the triangle symbol and then its 3 vertices. Each corner of a triangle we call a vertex. The plural of vertex is vertices. So this triangle might look something like this. We really don't know. But one point is J, another one K, another one L. Okay, but we really don't know much except for the coordinates on the coordinate plane of each vertex. I am not going to have you graph this on a graph. We don't have to in order for us to find a classification by side length. We are going to classify by side length if I'm using the distance formula. Okay? And so you remember, if you want to make a note on this page, the 3 classifications for side length are equilateral, isosceles, and scalene. Equilateral if all 3 sides are the same, isosceles if 2 of them are the same, and scalene where none of them are the same. Okay, so in order to do this problem, we're going to take a look at all 3 sides, and we're going to use the distance formula to find the length of each of the 3 sides. Okay, so first let's just pair up J and K. That would be this side. So we're going to find the length of JK by using your distance formula. X2 is the second x-coordinate, so if I'm looking at points J and K, the second x-coordinate is -9, minus the first x-coordinate, which would be -7. If we do -9 minus -7, we can change that to +7. Parentheses squared, plus the second y-coordinate is 1, minus the first y-coordinate is also -7, so I can make that a +7 and square that. And then we start to simplify this. We do the addition in parentheses first. -9 plus 7 is -2. 1 plus 7 is 8. Simplified a little bit further, -2 squared should be +4. Remember, when you put in a calculator, you've got to use the parentheses because this is -2 times -2. And 8 squared is 64. And then whenever I combine those one last time, I get the square root of 68. 68 is not a perfect square. You don't have to round this to a decimal. We can just leave it as the square root of 68 for now, because I just want to see if any of these side lengths are also the square root of 68. So now we're going to go and take a look at the distance formula for side KL. Okay, so we're going to use the second x-coordinate for KL, that's -1. Minus -9 becomes +9. Then for the y values, we use -1 for the second y value, minus +1. Then we continue to simplify this. -1 plus 9 is 8. -1 minus 1 is -2. 8 squared is 64. -2 squared is +4. And we also get 68. So this right here shows me that both JK and KL are congruent. And if I want to keep track on a little diagram, I can mark those two congruent to each other. So I know it's at least isosceles, if not equilateral. I have one more side to check, and that is JL. So I'm going to use J and L. I'm going to use the second x-coordinate, which is the one from L, -1, minus the x-coordinate from j, -7, that makes it +7. Then we do the same thing for the y's, -1 minus -7 becomes -1 plus 7 for the y's. -1 plus 7 is 6, so I have 6 squared. Again, -1 plus 7 is 6, there's another 6 squared. 6 squared is 36 for each of these. So if I add those 36's, I get the square root of 72. This is not the same as square root of 68 and square root of 68. So we get a third side that's not the same as the first two. Since I have two congruent sides only, I can say that triangle JKL is isosceles based on those lengths. All right, I want you to take a look at part B. We're going to do the same thing. We're going to use a different triangle JKL. And I want you to find the lengths of KL, and JL. If all three are the same, it's an equilateral triangle. If two are the same, it's isosceles. If we have three different lengths here, then that means all three sides are different, they're not congruent, then it's scalene. So I want you to find those lengths of each one, and then bring them to class. We will go over the answers to this problem in class together. I'm not going to complete it in the video. I want you to try and use your distance formula just like we did on the previous example to find JK, KL, and JL, find those lengths, and classify this as either equilateral, isosceles, or scalene.